Welcome to this explainer. Look, today we're throwing out the old playbook. We are going to completely rethink how we interact with our tools. Instead of treating the Google Antigravity CLI like just another standard chat window, we're going to treat it exactly like what it really is, the interactive control panel of a powerful autonomous development engine.
You know it, and I know it. The paradigm of software engineering has completely shifted. We've totally moved away from line-by-line coding to orchestrating intent. You're no longer just a typist cranking out syntax, you are a system architect. Your job now is commanding autonomous agents, defining their constraints, and setting up the operational boundaries for your new digital workforce.
So, here is our system startup checklist for today. We'll quickly cover the terminal native engineering shift, then dive into our dashboard dials, sandbox isolation safety vaults, autonomy and permission gradients, dialing thinking token budgets, and context compactions and memory. Finally, we'll wrap up with orchestration and enterprise governance.
All right, Section 1, the terminal native engineering shift, the new paradigm.
This is a massive shift. The Antigravity CLI does not just blindly write files, and it is definitely not a stateless chatbot. It actually executes a really rigorous loop. First, it observes, scanning your project definitions and current state. Then it plans, generating structured artifacts like an implementation plan for you to review. Next, it acts, using deterministic tool invocation via RPC. And finally, the best part, it verifies. It runs your test suites and actually executes self-healing loops if it hits a stack trace.
Moving right along to Section 2, Sandbox Isolation Safety Vaults, dialing in security.
Okay, let's grab the very first dial on our dashboard, Sandbox Isolation. Before you unleash an autonomous agent, you absolutely have to establish its physical boundaries. You do this using the sandbox parameter, which enforces OS-level execution containment. It physically restricts what the agent can touch or execute on your machine, which is crucial to ensure a rogue process doesn't just wipe your local files.
You're essentially operating between two extremes here. On one side, you have standard host execution, which is great when your agent needs to interact with local Docker daemons or host apps. But on the other side is the isolated container safety vault. You absolutely must lock your system down into this vault when executing untrusted libraries, pulling down brand new dependencies, or spinning up background subagents.
Which brings us to Section 3, Autonomy and Permission Gradients, Throttling Human Oversight.
Now for the second dial on our panel, the permission flag. This setting defines your operational trust tiers. It dictates the exact interactive threshold where the CLI pauses and says, "Hey, can I get your confirmation?" before running shell commands or applying any potentially destructive file diffs. You decide exactly when the agent must stop and ask you for the keys. Picture this like a physical slider. At the far left, you lock it to strict, step-by-step human confirmation mode. That's essential for core refactors or production database drops. But you can slide it all the way to the right into YOLO auto-execution mode when you're running sandbox test tasks in isolated Git branches where the blast radius is literally 0.
Section 4, dialing thinking token budgets, allocating cognitive power.
Look at the third instrument on our panel. It's essentially a processing meter for thinking tokens. You dial the engine high to dedicate massive chain-of-thought resources for resolving deep, distributed consensus bugs. Conversely, you dial it low to just speed through a simple documentation update or basic boilerplate scripting.
You're actively managing a cognitive budget here, and honestly, tuning this thinking token's dial efficiently based on the cognitive complexity of the task is exactly what separates a novice user from a master system architect. It completely eliminates this frustrating latency bottlenecks.
All right, Section 5, context compaction and memory preventing decay.
Let's hit the fourth dial. Context windows are finite, right? So they're subject to decay. Allowing verbose build logs or massive tool outputs to just accumulate in your buffer will severely degrade your agent's performance. It will literally cause the agent to forget your initial architectural constraints. The compact command is what regulates this history.
So how does it work? Without intervention, cluttered, verbose command histories pile up fast. But when you trigger the compact command, you physically compress the noise. All those bloated tool outputs get programmatically crunched down into tiny, lightweight metadata blocks. This preserves the agent's memory of your intent without the token bloat, slashing latency in half.
I want you to make this your rule of thumb. Aggressive memory management is the secret to speed. When you're deep in a marathon debugging session and things start dragging or drifting,
hit that compaction trigger to clear the fog.
Let's bring it all home in Section 6, Orchestration and Enterprise Governance, Safe Landing. When you're scaling this up for the enterprise, the crucial point is that LLMs can easily enter infinite failure loops. If a test fails because of a missing dependency, the agent might endlessly try and fail to fix it, draining your token budget. You have to govern your agents by configuring strict iteration caps, say 5 to 10 loops max, and set up automated circuit breakers that halt execution and roll back via a shadow Git branch if it gets stuck.
This is where the Antigravity SDK programmatic interceptor hooks come in as real game changers. An inspect hook handles compliance logging silently in the background. A decide hook fires right before a tool is used, acting as a blocking middleware to deny access to protected directories. And a transform hook? It can actually mutate payloads in transit to instantly scrub credentials, enforcing corporate security in real time.
At the absolute highest level of enterprise scaling, you aren't just piloting one agent anymore. You become the lead orchestrator of a hierarchical multi-agent topology. You deploy a coordinator agent that digests your high-level requirements, breaks them down into sub-goals, and then spawns parallel, isolated worker sub-agents across different work trees to, say, rewrite an entire monorepo simultaneously. It's wild.
This quote really hits the nail on the head. The core philosophy here is simple. Your value as an engineer is no longer in typing syntax. Your real value is in architecting the system, defining the invariants, and designing the automated verification loops that keep your autonomous workforce on track. By mastering these 4 dashboard dials, sandbox isolation, permission gradients, token budgets, and context compaction, you get complete, deterministic control over the system. You transition from dealing with unpredictable AI chats to conducting highly rigorous, scalable software engineering.
So here's the real question I want to leave you with before you boot up the CLI for your next big project. Are you still going to be a typist, or are you finally ready to step into the cockpit and take the controls of a truly autonomous development engine? Thanks for joining me on this explainer. Get out there and start building.